The following is an example problem detailing how to use binary search and binary search related methods to solve competitive programming problems. So this problem is from Codeforces, round 750. It's problem A, and a link will be provided in the description. I encourage you to try out the problem first. From trying it out on your first, either when you fail or succeed, and you come back and watch the solution, that will be a much better learning experience than someone just going through the solution. Surprisingly, even though it may seem as if you will learn a couple things from going through the solution, it's much more valuable to try the problem first. It doesn't really help you to just view the solution. So try the problem and come back. Okay, so now we'll begin. We know that we have two variables n and k. N is from 1 to 10, k is from 1 to 240. And in the problem, we start at 20, which is 10 o'clock, and we go up to, or 8 o'clock, and we go up to midnight. So that means we have 4 hours, and 60 minutes in an hour, so that's 240 minutes to solve our problems in this sample contest thing. So each problem will take I minutes. That means that to finish one problem, it'll take 5 minutes. To finish two problems, it'll take 5 plus 10, which is 15 minutes. To solve three problems, 5 plus 10 plus 15 is 30 minutes. And one thing that we can... one thing before that is we also have to consider that it takes time to reach the party. So in total, the amount of time that you have to solve the problem, let's say it takes k minutes to go to the party, so we will have 240 minus k minutes to actually do the problems. So now that we have this value 240 minus k, what we want to do is basically we want to figure out how many problems we can solve in that amount of time that we have, 240 minus k. And one thing that we might realize is that since n is so small, we can just pre-compute all of the possible times that there could be of solving n problems. Obviously, if you can solve 5 problems, that means that you can solve 4 problems. So we should always greedily pick the largest possible value that will fit. And that's one special thing that indicates that there's going to be a binary search solution. So if you have some table that basically looks like this: true, 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 and then you have all falses. Okay, I'll just do F. What that means is that now you're able to use binary search to find this true solution, to find the first value that's true. When you see something like this, that usually indicates you're going to be using binary search. So in this case, our Boolean is whether or not our value of 240 minus k is less than this time. So for the whole bunch of times, it will be like 0, 5, 15, 30, etc. We want to, if our value of time that we have to solve the problems is greater than 5, then we can see, then this will be true. If it's greater than 15, that'll be true, but if it's less than 30, it'll be false. So that indicates that there's going to be some binary search involved. So the first thing we'll do is we will pre-compute the possible times. That'll be very valuable for us, so we'll just create a time array. We'll just make it global. And I've already pre-computed the values, so it's 0, 15, 0, 5, 15, 30, 50, 75, 105, 140, 180, 225, and 275. One easy way to do this is that it's just that these are triangular numbers multiplied by 5. So that's basically what I did. And we have two variables n and k. Okay, so now we'll just set up our scanner. This, what I'm doing here, makes our makes our scanner much faster. So it's okay to use sin instead of using print what are they called, scanf, because those are much more difficult to actually use. Okay, let's just delete this. So we bring in our values of n and k, and the amount of time we have is 240 minus k. So now what we want to do is we want to say, so let's say our value of k is, let's just say k is 222, right? That means that the time we have to solve the problem is 240 minus 22, which equals 18. So what we want to say is that for this time 18, we want that to figure out where that fits into this time array. So we can see that we have enough time to solve 0 problems because 18 is greater than 0. We have enough time to solve 1 problem because 18 is greater than 5. We have enough to solve 2 problems because 18 is greater than 15. But we don't have enough time to solve any problems beyond. We don't have enough time to solve 3 or more problems because that requires more than 30 minutes. So what that means is that we're going to binary search and find the lowest value in this array that will fit. So instead of hand coding binary search, it's in a contest, you don't have a lot of time, so you want to use built-in methods as much as possible. So we're going to use a method called lower bound. And what lower bound does is when you put in a vector, it will find the first value. If you put in a value and some int x, lower bound will find the first value in your array that is greater than or equal to that value. So when I plug in 15, lower bound will return a pointer to 18. Will return a pointer to 30. If I put in 30, then lower bound will return a pointer towards this index. So we need to put in a vector, so let's just convert our array into a vector. V times plus 11. Great. So now we're going to find what the lower bound is. So one other thing, the C++ API a link will be provided in the description. So we'll say auto low. When you use auto as your type, that automatically fills in the type. It's actually an iterator, but we don't need to type in all of that extra stuff. b.begin, b.end, and we're looking for time. This value time where that fits into array, lower bound. So next, if we just convert that to an integer by doing low minus v.begin. So now we have our value. But there's one subtlety that we need to note, and that is that if we pick a value, like what's going to happen is, let's say we have 18, right? So 18 will give a pointer towards 30, but we don't have enough time to solve 3 problems. We have enough time to only solve 2 problems. So we're going to be having in the end val minus 1. But the problem is that if your val is, like, if you're lower bound, if you're searching for a time that's in the array, that means that your lower bound function will return the right index. So what we want to do is, to solve that problem, we're just going to say that if our value at the lower bound is equal to the time, this time that, like for example, if our k was, let's say our k was 190, then our time would be 50, right? So that will return a pointer to this value, and we say 50 will equal the time. So then we'll just do val plus 1. Val equals val plus 1. And that's because we're just going to subtract 1 from the value at the end. Finally, one thing that we do need to note is that the maximum number of problems that we can solve is limited by n. So we will just say that our output is the minimum value of n and val minus 1. And then we just return the output, and we're done.